Hi guys, it's Mrs. Harmison here with your advanced chemistry notes for chapter 11. We're going to go over solution concepts and solution calculations. When you have a solution, the liquid is called the solvent. Most of the time, that solvent is going to be water. Water is known as the universal solvent. In a solution, you also have either a gas or a solid that is dissolved in the liquid, and that is known as the solute. The whole thing together is called the solution. So in a solution, the solute is dissolved in the solvent. A solution with a relatively small amount of solute for the amount of solvent is a dilute solution. And a solution with a relatively large amount of solute for the amount of solvent is a concentrated solution. The definition of solubility: the maximum amount of solute that will dissolve in a given amount of solvent at a given temperature. In an unsaturated solution, the concentration of the solution is less than the solubility for that temperature. If the solution is saturated, the concentration of the solution is equal to the solubility for that temperature. And if the solution is supersaturated, the concentration of the solution is greater than the solubility for that temperature. Sometimes you can have a solution made of two different liquids. When that happens, the liquid that there is more of is the solvent, and the liquid that there is less of is the solute. Miscible is when two liquids dissolve completely in one another. Immiscible is when two liquids are insoluble with one another. Equations that you're going to need to work the problems in this chapter. We've already used this molarity equation. The thing to remember about it is that we have a volume in liters, and then this is the solution. And solution is the solute plus the solvent. The second equation is just a percentage equation. Both of these are mass in grams. And again, the bottom one is the solution. On this one, you want to make sure not to forget to multiply by 100. This is a brand new equation. The equation here is molality. The lowercase m is the unit. So if you said something had a molality of 14.5, it'd be 14.5 lowercase m. Or if it had a molality of 0.07, it'd be 0.07 lowercase m. Molality is moles of solute per kilograms of solvent. This is the one exception. The rest of these equations have solution, so the whole solution on the bottom, whereas this equation has kilograms of solvent. The mole fraction is moles of solute divided by moles of solution, and again, the solution is the solute plus the solvent. You will also need to use molar mass to convert from moles to grams and from grams to moles. And for some of the problems, you will need to use the density equation. In this problem, we have two different solutions. We have the solution that we're going to start with, and we have the solution that we're going to prepare. We know that the solution that we are going to prepare has a molarity of 0.25, and we also know that we have 0.55 liters of it. I slid the decimal to get that. So we want to figure out how many moles of that solution we need to make. So we're going to multiply these two numbers and we get 0.1375 moles. Now this other solution that we're going to start with, we know has a molarity of 12, and we know that we need to get 0.1375 moles out of it. So we are going to put an L down here for the liters. We're going to solve for the liter. And we end up with liters in the amount of 0.01146 liters. The question asks for milliliters, so we move the decimal over 3 and we get 11.5 milliliters as our answer. Okay, in this problem we're going to use the molality equation. Molality is equal to moles of solute over kilograms of solvent. We are given the molality, which is 0.531. We are asked to find grams, which we can do by solving for moles. And then we have grams of water. Water is the solvent, but we need to change that to kilograms. So we're going to say 0.525 kilograms. We're going to take 0.531 times 0.525 and get 0.2788 moles. And our substance is manganese nitrate. And then to convert this from moles to grams, like our answer asks, we add the molar mass up. We say that 1 mole is equal to 178.96 grams, which gives us a final answer of 48.9 grams. In this problem, we are also going to use the molality equation. Molality equals moles of solute over the kilograms of the solvent. We are going to be solving for this bottom part here, only it's asking for grams, so we'll have to convert. To start out with, it does give us the molality. It doesn't give us moles of solute, but it gives us grams. So we can take 16.5 grams of chromium 3 nitrate, and we can convert that to moles using molar mass. When we divide by the molar mass, we end up with 0.06932 moles, which we can put that number over here. Now down here is the kilograms, which is mass is what we need to solve for. Since it asks for grams, we need to convert this to grams, and we get an answer of 154 grams. All right, this problem asks for percent by mass. The formula for percent by mass is grams of solute divided by grams of solution times 100. We're looking to solve for the percent. We have the grams of solute, which is 5.65 grams, and then the grams of the solution. So the grams of the solution is going to be the grams of the solute plus the grams of the solvent. So we're going to put those in parentheses when we type it in, multiply by 100. And when we type all of that in, we get 24.6%. For this problem, we want to find the molality of hydrochloric acid. The molality formula is moles of solute divided by kilograms of solvent. Okay, and a reminder that solvent is not the solution. It's just the water. Our molality is equal to some number of moles of HCl that we don't know yet divided by some number of kilograms of water. Okay, so we need to find both of these things. The problem tells us that the percent by mass is 3.50. So this is going to be the grams of solution, and this is going to be the grams of the hydrochloric acid. What we can do is we can assign this solution a mass. So I like to use easy numbers like 100 grams. So if I assign the solution the mass of 100 grams, and then I solve for this mass up here, I'm taking 3.5 divided by 100 times 100, so I end up with 3.5. So if I have 3.5 grams of hydrochloric acid, I can convert that to moles of hydrochloric acid by dividing by the molar mass. And when I do that, I get 0.095996 moles, which I'm going to put way up here. Okay, now I want to find the kilograms of the water. So if I know that I have 100 grams of the solution, and the solution itself is equal to the solute plus the solvent. So 100 grams equals the mass of the solute, which is 3.5 grams, plus the mass of the water. We can figure out the mass of the water by taking 100 minus 3.5. So the mass of the water in this case is 96.5 grams. Now up here we want to have kilograms, so we slide the decimal. We get 0.0965 kilograms of water. And then when we type this in, we get a molality of 0.995. Little m for molality, and HCl is our substance.